Bismillahirrahmanirrahim. Assalamu alaikum. Welcome in the online classes of Ismailia Youth Services, and I am your teacher. And I teach you mathematics, and I am from Mohammedi Girls School. Before starting the lecture, I would like to tell you the instructions which are very helpful during the online class, and you have to follow these instructions. The instructions are: don't raise hand during teaching, listen the lecture carefully. If there is any disconnectivity, then join class again within 5 to 10 minutes. If you want to ask any questions, then you can ask at the end of the class. Now, moving on to the name of the chapter. This is chapter number 1, sets, and this lecture is for class. Today's objectives are the equivalent set and the equal set. So, first we started with the equivalent set. The definition of the equivalent set is the two sets are equivalent if they have the same number of elements. We have an example, so it will, if A and B are the equivalent, means that the set A is equivalent to set B. For example, if set A is having members A, B, C, D, and set B having the members 1, 2, 3. So it's having how many elements, how many members in this set? Set A, we are having 4 members in this set, and set B, we are having 4 elements as well. So the both having the same number of members in these both of the sets. So it means that they are the equivalent sets. This is not necessary that the same members are also present in these sets, but the number of elements are same, so it means that we consider this type of set as a equivalent set. Now, the equal set. What is the definition of equal set? Two sets are equal if they have exactly the same elements. Same elements means that we are not talking about the number of elements present in the set. We are talking about the members which are similar in both of the sets. Set A is equals to set B means that A and B contains exactly the same members, therefore they are equal. Therefore, we can write A is equals to B, means that A is the equal set of B. If A is equal to B, then A is also equivalent to B as well. It means that if we are saying that set A is equals to set B, so we can also say that set B is equals to set A. If A is equal to B, then A is might not be equal to B. Okay, now these are the, if we have 3, 5, 7, and we have 5, 7, 3. So this is set A we consider, and then this set we consider set B. So observe both of the sets. This set is having the elements 3, 5, 7, and the other set having the elements 5, 7, 3. So they both are the equal set. Why they are the equal set? Because they having the same number of elements in both of the sets. But if you observe the second example, 8, we having the set 8, 6, 10, and 12, and then we have another set which having 3, 2, 4, 6. So both of the sets having how many elements? Both of the sets having 4 elements, both in both of the sets. But if we observe that the elements are present in both of the sets are not same. So whenever we are talking about the equivalent set, so we only consider the number of elements must be same in both of the sets. But if we considered a equal set, so it is necessary that we have both in this we have same elements in. Moving on to the next third example, that is 7 to 1. This set means we considered, if we considered set A having elements 7 to 1, and we considered the set B having elements 1 to 7, so this is called a equal set. Why it's a equal set? Because they having the same number of elements as well, and they having the same members as well in both of the sets. Now, moving on to the next one, subset. Now, subsets, set which are the part of another set are called the subset of the original set. Means that whenever we are talking about the subset, so we have a universal set. The set which is denoted with U, and it's called a universal set. From the universal set, we are forming number of subsets. means that in the universal set we have all the numbers. By the help of that universal set we are forming a smaller sets which are called the subset of that universal sets. For example, if we have a is equals to 3568 and b is equals to 356, so a having the same element 3, b having b also having 3, and then we have 5 is also the same. Example, if a is equals to 3568 and b is equals to 356, so if you observe this clearly, you notice that set A is having the element 3 like set B, and set A having 5 and set B also having 5. Then we observe that set A having the element 6 and B also have the element 6 in it. So it means that they have the same member of approximately. It means that by from set A we are forming the subset B. Then B is a subset of A. It is represented by B subset A. Every set is a subset of itself. Means that every set is a subset of itself, means that whenever whatever we have the set or whatever we have the elements in the set, so it is also a subset of that particular set which we are forming. Empty set is a subset of every element, means that if we have sorry, every element I'm saying, every set is a set of every set, means that if we are forming an empty set or we are writing an empty set according to the universal set or the set which we have, so it means that the empty set is a subset of that the original one. Universal set, I just give you the example before that the universal, if we having this universal set and in this universal set we having 1 3 5 7 9 11 and 13, these are the elements of this universal set. Then which of the following are the subsets of? Okay, the first one we have A is equals to 2 and 4. You observe that we don't have 3, 2 and 4 in the universal set. It means that A is not a subset of the universal set. Okay, I told you that B is equals to a null set. B equals to a null set. So every null set is the subset of a original one. So it means that B is the subset of the universal set. Now then we have set C. Set C having 1, 9, 5 and 13. These are the elements of set C, and if we observe, then we consider that 1 and 1 is also present in set C, 9 is also present in set C. Then we have the universal set, and the universal set having 5 as well and 30. It means that set C is the subset of the universal set. To 5, 11 and 1. So 5 and 11, 5, 11 and 1 is also present in the universal set. So it means that D is also a subset of. We have E. E is equals to 13, 7, 9, 11, 5, 3 and 1. This is the opposite set of the universal set, but this is not the subset of the universal set as well, because it's having all the members of the universal set. Then we have set F. Set F is equals to 2, 3, 4, 5. So if you observe, then we don't have u in this set, sorry, we don't have 2 in the universal set, we don't have 4 in the universal set, so it means that F is not the subset of the universal set. Superset, every subset which is formed with the original one, so it means that the original set is called a superset, means that we are forming the smaller sets from the original one or the universal set, so it means that that universal set is a superset and we are forming the subset. The definition is a proper subset of a set A is a superset of A that is not equal to A. In other words, if B is a proper subset of A, then all elements of A are in B, but B contains at least one element that is not A. For example, if A is equals to 1, 3, 5, means that 1, 3, 5 are the elements and the name of the set set. And set B is equals to 1, 3, 4, 5 is a proper subset of A. Why it's a proper subset of A? Because set A having, set B having all the elements of set A. The set C is equals to 135 is an improper subset of A, but it is not a proper subset of A since C is equals to 137, means that set D having three elements which are 137 is not even an improper subset of A since D does not containing the element 5, but B is the superset of. Now, for example, let A is equals to A, E, I, O, U. These are the vowels and these are the members of set A, and B is equals to A, C, D, E. Means that is A superset of B, and also give the reason, you have to give the reason. So if we having this example, so it means that A is equals to A, E, I, O, U, and B equals to A, C, D, E. This means that set A is not a superset of set B. Why it's not a superset of set B? Because the elements C and D in set B are not present in set A, and element D is not present in set A. Set A is the superset and set B is the subset. So set B is not a subset of A because it's not having two elements, or we are saying that the two elements are missing from that set. Hence A is not a superset of B. We can also say that B is not a subset of. So whenever we have these type of sets, so we consider that if they having no same elements in the subset, so it means that A is not a superset. Is equals to A, E, I, O, U, and B is equals to A, B, C, then till Z, means that all the alphabets are present in set B, and this time set B becomes a universal set. So from set B we are forming set A. It doesn't mean that we are forming subset from set A. We are forming a subset A in from the superset set B. Hence A and B is a subset of B, and B is a subset of A, and B is the superset of A as well. Be the proper subset of any given set A if B has some elements from the set A but B is not equal to the set. For example, if we have A is equals to 1, 2, 3, 4, 5, 6, means these are the elements from 1 to 6 in 1, 2, 3, 4. So B is a proper subset of the set A. Why it's a proper subset of A? Because it's having all the elements of set A. Any set A, null set is a subset of A, and A is also a subset of A as well. For example, all the possible subsets of X and Y. If we have the two sets X and Y, and we are forming the subsets from X and Y, so we are forming these four types of subsets from X and Y elements. Means that null set is also a proper subset, because I told you in the starting of the lecture that any null set is a subset of the original one. So it means that null set is a proper set. Set X means the same element. So X is the proper subset as well, Y is a proper subset as well, and X and Y are the improper subset. Why X and Y are the improper subsets? Because a set of n distinct elements has two subsets, so there is not a possibility for this set in set X and Y. Now, for example, if we have A is equals to 1, 2, 3, 4, hence A is equals to 4 elements, means that A having how many elements into it? 4 elements. And if we having B having 1, 2, 3, 4, 5, means that it's having 1 till 5, means that it's having how many elements into it? 5 elements. So it is very much clear that set A having 4 elements and set B having 5 elements. So we observe that all the elements of set A are present in set B, but the element set 5, element 5 is not present in set B. So it means that B is not present in A. So we say that A is a proper subset of B. Symbolically, we write like this: A is a subset of B. Means that if we consider that we having the original set is set B, which having 5 elements into it, and we are forming a subset or a proper subset from set B, which is A. Now, The improper subset. What is the improper subset? An improper subset is a subset containing every element of the original set. A proper subset contains some but all the elements of the original one. For example, considered a set 1, 2, 3, 4, 5, 6. Then 1, 2, 4 and 1, only a single element as well, are the proper subset. While if we are writing 1, 2, 3, 4, 5, 6 is an improper subset. Why it's an improper subset? Because it's containing every same element like the original one. The overlapping set. The example and the overlapping set definition first we have discussed. So two sets A and B are said to be an overlapping if they contain at least one element in common. Means that the set which having both of the sets which having one single element or maybe two elements are same in both of the sets, it means that it's a overlapping set. It's not a equal set, it's not a equivalent set, it's a overlapping set. Why it's a overlapping set? Because it's having maybe one or maybe more than one elements common in both of the sets. So if we observe the example that A is equals to A, B, C, D and B is equals to A, E, I, O, U, it means that A is the similar one in both of the sets and nothing is same nothing is same in both of the sets. So it means that A and B are the overlapping sets. Now now moving on to the disjoint sets. What are the disjoint sets? Two sets are called the disjoint if they have no element in common. This is the very simple one. Means that for example, if we having set S equals to 2, 4, 6 and 8, means that it's having four elements, and set T equals to the CE is having the same elements like set S, means that they both having the four elements in. But if we consider that the number of elements are same but the elements of both of the sets are not same, means that it's having 2 and there is no 2 in set T. If it's having 4 and there is no 4 in set T as well, 6 and 8 as well, means that this is the set of even numbers and this is the set of odd numbers, and they both are not same number of same. Okay, now the Venn diagrams as well. A Venn diagram is a graphical representation of a set by regions in the plane. If you observe the first example is a disjoint set. Why it's a disjoint set? The property of the set is a disjoint set. Why it's called a disjoint set? Because the sets they don't have any common element into them, means that A equals to 1, 3, 5, 6 and B equals to 7, 8, 9. So they both are the disjoint sets because they don't have the common element into them. If we are talking about the overlapping sets and you observe the property, so first we have to set A, it's having the elements 1, 3, 5 and set B having the elements 5, 6, 8. So 5 is the same element in both of the sets. It means that this type of set is a overlapping set. I told you that whenever we having a overlapping set, so in the overlapping sets we having only a single element or maybe more than one elements which are common in both of the sets, so it forms the overlapping sets. Then we have the subset and the superset. Observe it. So B equals to 1, 3, 7, 8. This is the larger set and this is also the superset, and by this superset we are forming a subset. A is equals to 1 and 3. So A having the same elements 1 and 3 which are present in set B as well. So it means that set A is a subset of B and B is the superset of set A. And whenever we are forming the Venn diagram of the subset and superset, so we are not overlapping the both of the sides, we are forming the bigger or the larger, and we are forming the smaller one inside it, because by the larger set or the by the universal set we are forming the exercise. Find whether the set P and Q are the overlapping set or the disjoint sets. So the first set we have, which is P equals to 10, 20, 30, 40 and Q equals to 15, 25, 35 and 45. So if you observe both of the sets and what we considered about the property of this set,